All right, guys, here's this problem. Practicing our study of electric fields. Okay, from the reference tables, equation sheets, E equals, I don't like this value. I like to write it this way. I like to write it, let's go in this color. E equals KQ over R squared. Right, so we've got this charge Q1 of negative 16 microcoulombs, right? Times 10 to the minus 6, that's a microcoulomb, is fixed on the x-axis, and this is 9 microcoulombs. One's negative, one's positive, fixed at this point, 3 meters. Question 1, calculate the magnitude of the E field from E1 at the origin, 0 due to Q1. So here we go. The E of Q1 at the origin equals KQ over R squared. K, also from the reference tables, Coulomb's constant, 9 times 10 to the 9th Newton meters squared per Coulomb squared, multiplied by the charge, Q1 is negative 16 microcoulombs, divided by the distance of Q1, 1, 2, 3, 4 meters squared. All right, before we have to do any real math, this is kind of nice. 4 squared is 16, and that's 16. So that's going to cancel each other out. Meters squared is going to cancel out those meters squared. One of these coulombs will cancel out one of those other coulombs. So this we're going to get 9 times 10 to the 9th multiplied by 1 times 10 to the minus 6. That's a micro. So we're going to get 9 times 10 to the 3rd newtons per coulomb. That's it, or 9,000 newtons per coulomb. Let's try, that's it. That's number 1. Calculate the magnitude, 9,000 newtons per coulomb. For the second one, E from Q2, same equation, KQ over R squared, K, 9 times 10 to the 9th Newton meters squared per Coulomb squared, multiplied by the charge. The charge of Q2 is 9 times 10 to the minus 6th. 9 times 10 to the minus 6th. Another way to write that, you could say, is 9 microcoulombs. Okay? Divided by this Q2 is 1, 2, 3, 3 meters above the origin. It's on the y-axis. So here, oh wait, what's 3 squared? 3 squared is 9. That's going to vanish again. This is so pleasant. 9s cancel out. Meter squareds cancel out. Forgot to write the coulomb. Coulomb's going to cancel out one of those coulombs. So we get 9 times, same thing. 9 times 10 to the 3rd newtons per coulomb. That's it. Now the next part of the problem is to draw and label vectors. So here's what we've got. We've got from Q1, one second. Important ideas. This is negative, right? We have to go into negative. So Q1 is going to be that way. Q2, this Q2 is positive, out from positive. So that'll be down. So now when we go to draw this, from Q2, we're going to have a vector down. I don't know, making up some lengths, but an equal vector to the right. This way, 9,000, 9,000. It's going to be something like that. Now, do this math, vector addition. That way, when we add them tip to tail. So basically what we have to do, we have to have 9,000 newtons per coulomb over here and 9,000 newtons per coulomb over there. The resultant will be, right? Doing Pythagorean, 9,000 plus 9,000. The E at the origin, let's make that a little smaller. The overall E at the origin is going to be 9,000 squared plus 9,000 squared. Second square root, second answer, 12,000. 728 newtons per coulomb. Down and right, 45 degrees. Nothing too crazy.